Okay, so one more example, this one a little bit more complicated and having a little bit more to do with inequalities than our previous examples. The more complicated the problem type grows, the more we're going to have to think about inequalities and what it means to be less than and what we're really trying to accomplish in the problem. So we start this one in the same place as the other problems with preliminary analysis. We say to ourselves, okay, the preliminary analysis is an evaluation of making sure that the absolute value of the difference between the height and the limit is less than some epsilon value. Right? And what we're looking for is we're looking to evaluate something about x minus c. And say, okay, something here matters. And so we're looking for that absolute value of x minus c. In this problem, we get the absolute value of x minus the absolute value of c. It's less than epsilon, and we're looking for x minus c. So I need to adapt the problem because I don't see x minus c yet, but I can transform the problem that I'm looking at by using the conjugate to introduce that x minus c on top. We don't usually use the conjugate like this, although it's used in calculus more as a way to change the form of the problem to get the piece that you're looking for. And so I get x minus c on top over absolute value of root x plus root c, and that's less than epsilon. Okay, so that's a nice start. I'm not quite there yet. I'll make the claim that the next thing I can write is just the absolute value of the top, because we know that both square roots on the bottom produce positive numbers. So that's going to be a sum between the two of them, and that's going to be positive. So it doesn't need to be under the absolute value anymore. But the next question is, should I do this? Should I simply multiply now, as we've been doing before, this problem? And if we think forward to the end of the problem, the answer for ourselves should be no, because I don't want this square root of x involved. Right? In all of our previous problems, we always chose something like delta equals epsilon over 2. To introduce something like delta equals epsilon times x doesn't really get us where we want to in the problem, and we want a firm value, not something that's dependent upon the variable choice, what x happens to be. So we can't just simply multiply that root x over. What we need to do is maybe write another expression, a simpler expression, that still fulfills the same goal. Right? And I'm going to make the claim that this fills the same need. Okay. And the claim occurs right here in this relationship between these two pieces. All right. When we're writing inequalities, we can write these intermediate inequalities that get us to the same place, essentially. Right? But remember that I'm picking a delta, right, such that I'm less than epsilon. So if I pick a delta for an expression which is larger, okay, the second expression is larger than the first. That's important, right? It's got to be larger because the denominator, if I look at the relationships between the denominators, root x plus root c is greater than root c. Right? So the second expression, therefore, is larger because of that. Therefore, any solution that I get, any solution for x minus c over root c will work for x minus c over root x plus root c. Because as long as I'm picking values for delta, right, that cause the expression to be less than epsilon. If those values of delta work for a larger expression, they're going to work for the smaller expression, the one that's less than it as well. So that preliminary analysis ends with x minus c being less than epsilon times root c. Okay, so then we're ready for the formal proof itself. Notice how long the preliminary analysis is. The formal proof always relies on that same set of ideas. So when I hop back into the formal proof, I start with the absolute value of root x minus root c. I say, well, that's equal to x minus c over the square root of x plus the square root of c. Right? That's the same as x minus c over square root of x plus square root of c. I can use that idea that I did before. Say, oh, well, that's less than or equal to the absolute value of x minus c over root c. Right? And all that matters is that at the end, I go from my initial statement all the way down to epsilon. This expression is going to be less than delta over the square root of c. And then when I replace delta with epsilon square root of c over square root of c, I'm left with epsilon. And again, our formal proof checks out. So obviously the step in here that's a little confusing is the step in which I reduce the denominator. Right? This is the confusing step. And the power of these transitive chains is thinking about, right, I don't necessarily need to prove that everything is equal, right? But I can show that 5 is less than 8 by showing that 7 is less than 8 and 5 is less than 7. Right? So if I can't, and that's a silly example because we know all of those things to be true. But if I don't know about the endpoints, right, then I can pick a point in the middle and show its relationship to each individual piece. And that's essentially what we're doing here. And actually, I'll have one example like this to practice on your homework as well.